In this problem, we're given the graph of height as a function of time for a simple harmonic oscillator. We're also told the mass of the oscillator, by the way, that's 95 grams. And we're told that on this graph, the vertical grid units represent centimeters and the horizontal grid units represent 0.5 seconds each. So we have a multi-part problem here, where in part A, we're finding the period and frequency of the oscillation. In part B, the amplitude. So those are easy enough. But then in part C is the real problem. We want to compute the spring constant by studying this graph. So to find the period of oscillation, we just have to count how much time it takes for our oscillator to complete one full oscillation. And I'm just going to go ahead and start at the top right here and then count the spaces. 1, 2, 3, 4 spaces before I return to that initial position. Now with each space being worth half a second, that's 2 total seconds. So our period is going to be 2 seconds. Now we can quickly compute the frequency. Remember, that's the reciprocal of period, so 1 over the period. And the frequency comes out to 1 over 2 seconds. And remember, a 1 over second is the same thing as a hertz. So I'll go ahead and write this in decimal form. It's 0.5 hertz, and we've got the frequency. Now the amplitude, remember, that's the distance between the midline of this sinusoidal function and the extreme points at the top and bottom. So there's the midline as a dashed line, and I can see the highest point on this function is 3 centimeters above that, and the lowest point is 3 centimeters below that. That's an amplitude of 3 centimeters. So finally, we get to the problem that I said was like the real problem in this video, and that's finding the spring constant based on studying this graph. And the point there is that we have this relationship between period and the mass of the oscillator and the spring constant. So T is going to be 2 pi square root of m over k. What we're trying to solve for here is k, and we'll go ahead and do that symbolically before we plug in any numbers. But just note there that we already know the period and we know the mass, so we know it's possible to solve for k. So I'm going to divide by 2 pi on both sides and then square both sides in my first step here. And I get t squared over 4 pi squared is equal to m over k. And then we'll go ahead and multiply both sides by k to move that over to the left. And we'll multiply by the reciprocal of t squared over 4 pi squared. So we find that k is equal to 4 pi squared m divided by t squared. So we need to be careful to plug everything in SI base units. And so I get k equals 4 pi squared times m. That was given to us as 95 grams, and we need to convert that to kilograms. So that's 0.095 kilograms. And then I have to divide by t squared. So that's 2 squared. And I will check the units on this to make sure they make sense after we get a number on the answer. So to 3 significant digits, this comes out to 0.938 newtons per meter for the spring constant. And let's just go ahead and check the units real quick. When I plug it into this formula where I have an m in the numerator and a t squared in the denominator, those are units of kilograms in the numerator and seconds squared in the denominator. So how are we getting newtons per meter out of this? Remember from Newton's second law, F equals ma. A newton is a kilogram meter per second squared. So if I just take my kilograms over seconds squared and I multiply the top and bottom by meters, I can write this as kilogram meters per second squared. Okay, and that took care of our kilograms and our meters in the numerator and our seconds squared in the denominator. And then I have a leftover meters in the denominator. So the kilogram meter per second squared, that's a newton. And then I have a 1 over meters here, so I can write this as newtons per meter. And I get the correct units for a spring constant. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.